All right, I'd like to bring together a lot of the ideas we've been doing over the past, weeks of the course in what's known as static equilibrium problems. So in static equilibrium problems, basically the situation that we want to evaluate is the following one. Okay, imagine that you have, uh, it could be a building, bridge, a human body, etc., whatever, that is completely still. It's stationary, it's not doing anything. Like a good example is, let's say we wanted to design a building or something. Our goal in designing a building would be to create something which is not moving. We've been focusing a lot on this course in motion, but equally important is how to know when something is not moving. This also has implications for the human body, like say in sports technique, for example. Let's say you want to come up with like a stance that you can put your body in so that you'll be completely able to be still and kind of stable and stationary. What determines that something can be still? That's going to be the central question of this section. And the answer should be quite obvious if you think about it for a second. In order for something to be still, in order for something to be completely still, it must have acceleration 0, and it must have also rotational acceleration 0. In other words, the object cannot be moving, and the object also cannot be rotating. And if it's going to be stationary over time, then it can't have an acceleration or rotational acceleration, because the velocity of the object and the angular velocity of the object have to be unchanging over time. So as a result, F equals ma tells us that the total net force on the object is 0, and tau equals I alpha tells us that the total net torque on the object is 0. So both of those have to be true. The total net force on the object is 0, and also the total net torque on the object is 0. So that is referred to as something being in static equilibrium, when both the acceleration slash the net force and also the angular acceleration slash the net torque is equal to 0, so that the object is capable of remaining completely still over time. So let's say that we flip this around and a question tells you, we know that something is at static equilibrium. How does that affect your problem solving? So if something is at static equilibrium, we can do the following. Number one, draw its FBD, draw its free body diagram, and write its F equals ma equation with a equal to 0. So basically we can sum up all the forces on the object and say that's equal to 0. And then number two, we can also draw its rotational FBD with all the forces in the correct locations and write its tau equals I alpha equation with alpha equals 0. And that must also be true. So basically, take all the skills you learned in the F equals ma portion of the course to build the F equals ma equation, then take all the skills you learned in the course in constructing tau equals I alpha equations and do possibly both of them on the same system to prove that it's in static equilibrium and solve for whatever you might need to solve for. So that's the basic idea. If you see that something is completely still and stationary, it's not moving, it's not rotating, What you want to do now is think about both of those procedures, both of those frameworks simultaneously. So I'll show you an example of that in the next video.